Best teachers पढ़ाए तो simple लगे everything. Leaderboards and quizzes से
Amazing.
learning हो जाए happening. समझ आएगा तो मजा आएगा.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hey guys, welcome to Vedantu's JEE channel, and I'm back with another interesting session of the Killer 5. Yes, you can see it on the screen. Today's topic is the much awaited session, and yes, the topic is on optics. Okay guys, so following the trend, we'll be picking up 5 very important and relatively challenging questions from the unit of optics, and we are going to crack them one by one. Okay, so if you're ready, then just have your copy and pen with you, start solving along with me. Okay, so here we go, and let's have a look at the very first problem. So what you see on your screen is the very first question, which is from the wave optics part, and the question is from JEE 2017. Okay guys, the question says that in a Young's double slit experiment, slits are separated by 0.5 millimeter. Okay, so let me along with this start writing. So D is given to us as 0.5 millimeter. Okay, and the screen is placed at 150 centimeter away, which is basically capital D. So that is 150 centimeter, or you can call it 1.5 meters. Okay, and a beam of light which consists of two wavelengths, one is 650 nanometer, the other one is 520 nanometer, and these are used simultaneously to obtain the interference fringes on the screen in front of the two sources. Okay, so the least distance from the common central maximum to where the bright fringes due to both the wavelengths will coincide. Okay, that's what basically the question wants us to find out. Both the wavelengths are being given to us as 650 and 520 nanometer, and you know that in a YDSE experiment we have light waves coming, and from two sources these light waves reach and they interfere, and because of the superposition of the light waves, if the constructive interference takes place, the maxima happens, the maximum brightness intensity is found, and if destructive interference takes place, then what you find is basically a dark spot, and that's basically is the result of destructive interference. So this distance between the two sources is small d, and the distance of the screen from the sources is capital D, and this is basically the distance of maximas or minimas. So in this particular situation, you are using two colors of wavelengths. One is of 650 nanometer, the other one is of 520 nanometer, and they will have their own ways of creating maximas. We know that the location of any maxima is calculated as n lambda capital D by small d. So because y is depending on lambda and two lambdas are different, so there will come a point where both the waves, one 650 nanometer, other one is 520 nanometer, will coincide their maximas at a given point. So we want to basically locate that point where both the maximas will coincide, will overlap with each other. Okay, so let's go ahead and try to find that out. So guys, in this particular situation, what is given to us is that y has to be same for both, which is n lambda capital D by small d. Now for both the waves, because capital D and small d is same, small d is given to us as 0.5 millimeter, capital D is given to us as 150 centimeter or 1.5 meter. So we can say that if y has to be same, n and lambda are supposed to be same. Okay, n is basically the nth bright fringe we are talking about. So what basically will have to be same for both the light waves is n1 lambda 1 equal to n2 lambda 2. Basically I'm equating y. Okay, so it means that n1 upon n2 means which of the maximas of the two wavelengths will coincide with each other is basically what we are trying to trace here. So this is lambda 2 by lambda 1. Okay, now what is lambda 2? Lambda 2 is 520 nanometers, and lambda 1 is 650 nanometer. This 0 gets cancelled. You can see these are both multiples of number 13. So this goes 4 times and this goes 5 times. Which means what? Now we know that if we take the first possibilities, then in this case n1 is coming out to be 4, n2 is coming out to be 5th, means we can say that for lambda 1 650 nanometer, its fourth bright fringe, and for lambda, that is 520 nanometer, its fifth bright fringe will overlap with each other. And now we are interested in locating that. Okay, so what we are going to do now, we are going to calculate the value of y for any one of the wave, because that location has to be same for both the maximas. So we'll be calculating, say, n1 lambda 1 capital D by small d. Okay, so n1, I'm choosing it for, say, 650 nanometer. So n1 value will be 4 multiplied by 650 into 10 to the power minus 9 multiplied by d, that is 1.5, and divided by small d, which is 0.5 millimeter, or you can call it 5 into 10 to the power minus 4. Okay guys, which means what? If you cancel this, this will go 0.3 times 0.3, and 0.3 and 4 will multiply to give you 1.2. Multiply that by 650, and this becomes 10 to the power minus 5. Okay, so if I remove this 0 as well, then the fraction will be 65 into 10 to the power minus 4. Okay, so if you multiply this, what you get is 78 into 10 to the power minus 4 meters, which means what, guys? We can write it as 7.8 into 10 to the power minus 3 meters, or simply what we get y as, it comes out to be 7.8 millimeters. Okay, now what you can try by yourself is to use n2 lambda 2 capital D by small d. For n2, use the value 5, and lambda 2, use it as 520. Solve it and check and verify whether you get the correct answer as 7.8 millimeter or not. Okay, obviously you should. So that's why, that's basically a practice for you to do, and the correct answer to this question comes out to be option A, and that is 7.8 millimeter. Okay guys, I hope that you guys understood the question. Question is from wave optics, from a very interesting topic of interference. Many times this question comes or similar concept question comes in the chapter of mechanical waves as well. Okay, so guys, this was our very first question of Killer 5 series. I hope that you guys are able to understand this. If you guys find optics relatively challenging or any other particular chapter challenging, then I have a solution for all of you, and that is Vedantu micro course. Yes guys, micro course is basically what? This basically is availability for you of subjects and the chapters in them individually which you want to study. Means what? Instead of studying the entire physics, if you are just facing problem in, say, optics, or say in electrostatics, or say in any chapter of mechanics, then yes, Vedantu's micro course is just for you. What is the highlight of that? Well guys, it gives you the complete chapter discussion. It gives you key formula and concepts discussion, and the summary of the entire chapter along with the revision and in-class quizzes. The best part of it is that the course are starting at as minimum as 11 rupees. So do take advantage of that if you are facing trouble with a given chapter in any of the subjects during your JEE or NEET preparation. Go for a micro course, and while doing that, you have to follow this link and use this code SHMIC to avail 95% discount, so that the course for every chapter comes out to be as low as 11 rupees. And if you are a guy who want to do the entire syllabus in a crash course mode, then we have that possibility also for you. All you have to do is go on this link. When you are going to purchase the course, all you have to do is put down the coupon code. What is that coupon code that you have to use on the link? It is SMCC. If you use that, you'll be able to avail a huge discount. The course, which actually comes for rupees 15,999, you get it for just under 8,000 rupees. Okay guys, so if your requirement is to go for an individual chapter, go for a micro course. If your requirement is to study everything just before the examination in a crash course mode, the solution is here for all of you. Okay, cool. So let's go ahead. Let's have a look at the next question. The next question is from ray optics, and the question is there in front of you from 2003. JEE 2003 ka question hai guys. The question says that a ray of light is incident at the glass water interface at an angle I. So what you see here, that a light ray is incident at glass water interface at an angle I, and what happens after that? It emerges finally parallel to the surface of water. So finally when it is emerging parallel to the surface of water. That means angle of final angle of refraction is 90 degree. Okay, so we have to find out the value of refractive index of the glass. Glass refractive index is to be found, guys. Okay, so let's go ahead, and all the options are here in front of you. Let's try to solve this question. Cool. So whenever we are dealing with the basic understanding of refraction, the very primary law that we study in refraction is basically Snell's law. I'm sure you have heard about it. It's mu1 sin I equal to mu2 sin R. So what we are going to do, let's define the two interfaces. Let's call this as the first interface and this one as the second interface, and I'm going to apply Snell's law twice. That means what? I'm going to apply it on interface 1, where the angle of incidence is 1, and say the refractive index of glass is mu g. So I will write it as mu g sin I should be equal to mu water, because it is eventually going in water. Yeah, so there the angle has to become sin R. Okay, so this is interface 1. Same thing I will apply between water and air interface, that is interface 2. So there I will say mu water sin R, because if this angle is R, this is also R, should be equal to mu air, and finally the angle of emergence is 90 degree. Now what do you see here, guys? You can see that effectively these two could be equated. Mu g sin I can be equated to mu air sin 90 degree. So let's equate that and simplify it. So mu g sin I should be equal to mu a sin 90. Okay, so how much is the value of refractive index of air? I think you already know that value is 1. Sin 90 is also 1. That means mu g sin I should be equal to 1. Okay, means what? It simply lands us to the value of the refractive index of glass, which is mu g, as 1 upon sin I. Okay, guys, and if we check the options here, yes, one of the options, option B, happens to be the answer here. Okay, so a simple application of the Snell's law here, and what we have got is the refractive index of the glass when the light was actually traveling from one medium to the other, and it passes through totally 3 mediums here. Okay, guys, I hope you were able to solve this along with me. Okay, moving on to the next question. Well, here's the next question, and now this question is from prism. What you see here is one of the refracting surface of the prism of angle 30 degree. This angle is given as 30 degree, and one of its surface has been silvered. That means what? The reflection will happen irrespective of the angle of inclination. So a ray of light which is incident at an angle of 60 degree. So here the ray of light is incident at an angle of 60 degree, and what happens? This light after refraction also retraces the path finally. So what is the refractive index of the material of the prism is to be found, and what is already given to us apart from the options are that this angle is angle of prism, that is given as 30 degree. So if I say that angle of prism is 30 degree, angle of incidence has been given to us also, guys. If you look at the angle of incidence here, that is given to us as 60 degree. That is why if this angle is A, this angle is taken as 2A. Okay, so guys, if you follow the ray diagram here, you can see that if this angle is A and the light is retracing its path after reflection also, that only possibility which arises is when the light is incident along the normal. That means what? On the silvered surface, the light is going normally and getting reflected again, which simply means what? If this angle is 90, this angle is A, so the third angle of the triangle becomes 90 minus A. Okay, and this is the normal on the interface MO. So there, this angle has already been 90 minus A, so the remaining angle becomes A, right? Because this total angle has to be 90 degree. Okay, guys, so now what do I have? I have the angle of incidence as A, angle of refraction as, angle of incidence is 2A, angle of refraction is A, and what I'm supposed to find is basically the refractive index of this particular prism material. Cool, guys, so let's try to apply Snell's law here, and what Snell's law will say that mu air sin A should be equal to mu glass into sin this angle is 2a, so let's call it I first, and this will be sine r. So mu a sine I should be equal to mu g sine r, and let's put the respective values that we know. So refractive index of air is 1, angle of incidence is 2a, refractive index of glass is mu, and the angle of refraction is a, which is mentioned here. Okay, now what, this is sine 2a, so simple mathematics, this becomes 2 sine a cos a equal to mu, that is unknown, into sine a. Now what do you see here, sine a gets cancelled, and the value of angle of prism is given to us as 30 degree. That means we know the value of a, that means mu becomes 2 times cos 30 degree. Let's put that value. So 2 into cos 30, that is root 3 by 2. This cancels, that means mu comes out to be root 3, or we can say mu will be equal to 1.732. Okay guys, so the answer to this question comes out to be option A. Okay, so what was the interesting part to observe here is that when the light is retracing its path, it must had been incident on the reflecting surface along the normal, because for any other angle the light will reflect and will not retrace its path. Okay, cool. So let's move on to the next question. Well, this is the next question for all of you. What does the question say? Question says again that there is a prism, a parallel beam of light is incident at an angle of alpha. So what do you see here on this surface, that is PQ, a light is incident at an angle of alpha, light ray, a bunch of light ray will be called as a beam, and the angle of incidence is given as alpha, and on the side of a right angle triangular prism whose refractive index is say n, which is given to us as root 2. Okay, so the light undergoes total internal reflection in the prism at the face PR. So at the surface PR, what happens, the light will get total internally reflected, which means what, the light is incident at the critical angle. I hope that you know this concept, that whenever the light is traveling from denser to rarer medium, so when it has entered inside, it is denser medium, it is trying to go out, which is rarer medium. So if the light is incident at an angle which is equal to or more than the critical angle, then the light will internally reflect. So here the critical angle has been given to us as 45 degree, and what the question wants us to find out is the angle of prism, that is theta. So theta is basically what we want to find out. What is given to us is basically the angle, the minimum value of the angle is being given to us. Okay, sorry, this is not critical angle. What is given to us is basically the value of alpha. This is the minimum value of alpha that is given to us. Okay, cool. So alpha is 45 degree. We don't know the critical angle, we know the refractive index, and what we know that if the light is coming at the critical angle, it will basically go parallel to the interface, just like this diagram if you try to understand this. Okay, so what you see here guys is basically what is happening in this question. So the light is incident at an angle alpha, after that it is entering in the medium, so obviously it is bending towards the normal, it is moving from rarer to denser medium. So let's say that this angle is angle of refraction, and after that the light is incident say at an angle that is critical angle, theta c. Okay, so we don't know the value of critical angle as well, and after that the light will be just grazing the surface, because this is the minimum possibility for the light to suffer the total internal reflection. So nothing has been mentioned that it is internally reflected inside, and the critical angle has not been given, and the angle at which it is incident is also not mentioned. So we'll assume that the light is going to trace the interface of glass and air eventually. The refractive index is also given to us. Okay guys, so what is known to us is the angle value alpha, its minimum value is given as 45 degree. So if I try to apply a Snell's law at this interface, that is PQ, so at PQ I can say that 1 into sine 45 degree, that is basically mu1 sine I is sine alpha, should be equal to mu glass. That value of mu glass is also given to us as root 2 times sine r. Okay, not writing the formula again and again because we have been using it in the previous question. So 1 into sine alpha equal to mu into sine r. Sine alpha is 45 degree value, so 1 by root 2. So I can say that sine r is equal to 1 by root 2 into 1 by root 2. Taking this root 2 also here, that means this value comes out to be 1 by 2, or simply I can say that the value of angle of refraction comes out to be 30 degree. Okay, so we have found the value of angle of refraction. This angle has been found here. So let me just rub it and write it down it as r equal to 30 degree. Okay guys, cool. Now if we talk about, say, the critical angle now, means what? So far we applied the Snell's law on surface PQ. Let's try to do that on PR now. So at PR, if we apply the same thing, this time what will happen? Root 2 is the refractive index of the first medium. Angle of incidence is theta c, which we do not know how much is that value going to be. This should be equal to refractive index into sine 90. Okay guys, that means sine theta c comes out to be, this value is 1. So this is 1 by root 2, which makes it theta c as 45 degree. So now we have the value of critical angle as well. This is 45 degrees. Okay. Cool. Now see this. So if you have this angle as theta and this angle you already know is 90 degree. So these two are internal angle and this one is the external angle. So you can say that this value will be 90 plus theta. Okay. Now see this. This is 30 degree. This is 90 plus theta, and let's call this angle as beta. So let's try to find out in this triangle the value of beta. We know that beta plus 90 plus theta plus 30 degree should be equal to 180 degree. Okay. So guys, from here this is 120 degree goes there, remains 60, theta also goes there, beta comes out to be 60 minus theta. So I have the value of beta also. Why do I need this angle? Is because this total angle is 90 degree. So now I know the value of beta, I know the value of theta c. Now I can find out the value of theta, which is the angle of prism. So from here I can say that theta c is equal to 90 minus beta. Okay, theta c is 45 degree. This is 90 minus 60 minus theta. So 60 minus theta will effectively make it minus 60 plus theta. So this is 30 degree, comes here, gives me the value of theta as 15 degree. Okay. So the correct answer to the question of angle of prism, if we look at the options here, is the first option, that is 15 degree. Okay. So this is how we solved the question here. We first found the value of angle of refraction, then angle of critical angle value. After that we worked out this angle beta because this total angle is 90 degree. So finally we got the value of theta here. Okay, I hope you liked the question. Cool. So moving on, coming to the last question of this Killer 5 series. Let's read the question purely here first. Now what does the question say? We have a thin convex lens made from crown glass whose mu value is 3 by 2, has a focal length as f. When it is measured in two different liquids having refractive indices as 4 by 3 and 5 by 3, it has the focal length as f1 and f2. So obviously different mediums, if you put the lens into, its value of focal length will come out to be different. So the correct relation between the focal lengths are to be checked, and the question is from JEE Advanced 2014. Okay guys, so what we are supposed to use here, very importantly for you to understand, that when we talk about the lens maker's formula, we usually write it as 1 by f equal to mu minus 1 upon r1 minus 1 upon r2 for the two radii of curvatures. Usually when you are writing this mu is taken with respect to air as the medium. But when we are using any other medium whose refractive index is other than 1, like here it is 4 by 3 and 5 by 3, so this mu will become mu relative. And how will you write mu relative? Mu relative is basically mu lens divided by mu surrounding medium. Okay, so that is what we'll be using, and we'll be finding out the value of the two focal lengths of the lens respectively. Also, one more thing for you to understand here guys, that when we speak about, say, this convex lens, what is important for us to keep the sign conventions in mind? When we are considering this first surface and this as second surface, so the first surface will have its center of curvature on the right side, so its radius will be measured on this side and will be considered positive, because this is the first surface and its center of curvature is on the right side. If you talk about the second curvature here, the center of curvature is on the left side, and when you will be measuring R2 will be measured to the left side and will be considered negative. So keep that in mind. Okay, so let's go ahead and try to solve this question. Cool. So guys, using the formula 1 upon f is equal to mu lens upon mu surrounding medium minus 1 times 1 upon r1 minus 1 upon r2. So using it now, so 1 upon f1 will be equal to mu lens. I'll need the data. So the data is 3 by 2, the refractive index of the lens, and 4 by 3. Okay, so 3 by 2 divided by 4 by 3 minus 1. First radius of curvature is positive, second radius of curvature is negative, and both are equal in magnitude. So both are written as R only, but first one is positive, second one is negative. Okay guys, so this becomes 3 by 2 into, this is written as 3 by 4 minus 1, and this becomes 1 by r plus 1 by r, that means 2 by r, and this when simplify 9 by 8, on simplifying 9 minus 8, that is 1. So 1 by 8 into 2 by r makes it 1 by 4r. This is 1 upon f1. Okay guys, so what we have so far, we have f1 equal to positive, and that is 4r. Okay, now we'll be going ahead. We have the value of refractive index of the medium, that is 5 by 3. So let's try to find out the value of 1 by f2. So 1 by f2 will be 3 by 2, which is mu l, and 5 by 3 minus 1 into 2 by r. So this makes it 3 by 2 into 3 by 5 minus 1 into 2 by r. So this is 9 by 10. That means it is going to be minus 1 by 10 into 2 by r. So this makes it minus 1 by 5r, or we can also write it as 1 upon minus 5r as 1 upon f2. This gives us the value of f2 as minus 5r. So f2 comes out to be negative, guys. Okay, so if we look at the options here, the options will have comparison with f also. So let's try to find out the value of 1 upon f, and 1 upon f value comes out to be mu minus 1, that is 3 by 2 minus 1 into 2 by r. So this value becomes 1 by 2, cancels with 2, so f value comes out to be 2. Okay, so f1 is 4r, f2 is minus 5r, and this value comes out to be r. Okay, so let me just rub it here so that we can read the options. So what do we see here? f1 equal to f2, you can see that f1 is not equal to f2. If we look at option D, f1 and f2 become negative. You can see that one of them is already positive. If we look at option C, f2 is greater than f and f1 becomes negative. f1 is positive, that is 4r. So that is why the correct answer has to be option B, where what is happening, f1 is greater than f, which you can see f1 is 4r, f is r, and f2 becomes negative, which is minus 5r. So yes, the correct answer to this question is option B. Okay guys, I hope you liked the question that we solved today, and if you guys are having fun with us already, then hit the like button to the channel. Okay, there is one more news that I want to share with you all. The Vedantu app that you guys are being using, that has been chosen as the best app on the Google Play Store. Thanks to all of you guys for your own support, that you have helped Vedantu bag the User's Choice App Award for 2019. Yes, this is not just a celebration for us, it is basically a celebration for all of you as well, because you guys are the real people for getting the credit to bring this Vedantu app to this huge platform and get this success, along with whatever has been shared with you guys have responded back. Cool guys, so I hope that you guys have had fun with me in this yet another session of JEE Sprint. So if you guys haven't done that yet, then hit like button to this channel. If you think that your friends can also take advantage of these sessions of JEE Sprint as well as the Killer 5 series, then just share with your friends as well so that they can also take the advantage of Vedantu. Also, you can share the link of the app as well. And if you haven't done so far, just subscribe to the channel. Cool guys, so I'll be seeing you again with more such videos. We'll keep on solving questions, we'll keep on sharing motivational tips with all of you guys. So till then, keep studying, keep smiling, and don't forget to enjoy the subject of physics. Bye bye.